Hey guys, Mr. Pettit here. Just looking at our next lesson. We're looking at sine law and finding angles. Finding angles. Okay. So what we're going to do here is our format here has to be a side angle side or a side side angle that we're looking at. Okay. So we have to have those types of formats when we're looking at a triangle. So we have to be given a side, side, and an angle, and then we got to see exactly where that angle is and make sure it's located directly across from its side. Okay? So I'm going to do the two examples that we have on our lesson, and we'll show you exactly what we're going to be doing with that right there. Okay? Okay, first thing we're going to look at is the first one, and we have A, B, and C. So A, B, and C. And in our example, we have 50 centimeters. We have 35 centimeters. And we also have 60 degrees down this corner. And we have X as our value. Well, remember what I talked about. When you have an angle that is bigger, obviously the angle is bigger here because we've got a longer side. This side's smaller, so this angle has to be less than 60 degrees. Just something that kind of gives you an idea of what you're looking at in that format. Okay? Now, remember what I said. Side, angle, side, or side, side, angle that you're given. But you also have to have an angle that's directly across from one of those sides. Okay? So a known angle directly across from one of the sides. So again, you can set this up as 50 over sine 60. And here I have my X goes with 35. So I have 35 all over sine X. Now that X, remember that X is an angle. It could also be B. I could also put sine B right there because that's really essentially what that angle is. But sometimes you don't have these vertices that are given to you. So you could just put that as X as an angle that you're searching for. Okay, so let me show you how to set this up. So setting this up by cross multiplying. So sine X multiplied by 50 equals sine 60 multiplied by 35. Now, again, sine angle is what we're given here. So this is separate. This right here is separate. So first step I got to do is I got to divide by 50 to get rid of it because I want to get down to an X as my value and go that route. So the first step I do is divide this by 50, divide this by 50, and now what I have is sine X equals sine 60 times 35 over 50. Okay, so there's the format right there. Now, remember what we talked about. This is not our ending. This is not our value here. We need to find X by itself, and we're finding an angle. So when we're finding an angle, our last step here is we have to be able to do our inverse function. So I'm going to bring this up to the top here and bring this all the way up here. So sine X equals sine 60 times 35 all over 50. Okay, that's what we have from down below here. To get X, what I have to do here is do the inverse function of this whole thing. Sine 60 times 35 all over 50 as our value. Now you can input that all the way through. You can do that. I got a calculator right here. What we can do is make sure it's in degree mode, and I can type in sine, so second function sine, bracket sine 60 times 35 divided by 50. We end up with the bracket, and I get my angle of 37.3 degrees as my value. And like we said before, we knew it was going to be less than 60 because that's what the side length was. It was less than 50, so we knew that was our format there. Okay, so that's the key function in that format. Again, it's an extra step, taking that 50 and dividing it out. And then once you have it here, then you can do the inverse function. The X can look at it as the inverse function to find the angle. Okay? All right, we're going to do the last one, the second one here, and then we're going to give you some examples, and then we're going to work on some of those today. Okay? All right. The next triangle we're looking at is this right here. It looks something like this. And it doesn't have vertices. Remember what I told you? It doesn't have vertices. Sometimes that happens. So we got 9 centimeters here. We have 14 centimeters here. And we have 65 degrees here. And we have our x. Okay? So again, we have a side-side angle or an angle side-side. Anything you're looking at in that format, this is the format. But again, this angle has to be across from this side length. If this 65 degrees was up at the top here and there was nothing below, we couldn't find it. We couldn't find the value because it has no angle with a side here. Here it has an angle with a side provided on the other side of it. Okay, so that's what you need. You need that to create that fraction. There's your fraction right there. 14 is the side length all over sine 65 because it's directly across from it. All right, now this is where it gets confusing. Some people put that x because they get so used to finding a side length. Remember, side lengths are on the outside, angles are in the inside. So when I see an x on the inside, I know it has to be combined with my sine value because sine angle is what you have in your formula. So we have 9 all over sine x as my angle. Same idea, cross multiply these, sine x multiplied by 14, sine 65 multiplied by 9. Okay? Again, you got to get rid of this 14 because we got to do it 2 steps here, multi-steps. So I got to divide this by 14, divide this by 14. Well, once I know that, and I know I'm finding an angle, I can go directly to x equaling the inverse function of sine 65 times 9 all over 14, and to get my x value here. Okay, so it's just eliminating a step, but we know, again, when we're finding an angle, we have to use that inverse function to do that. If you want to take that extra time and put that step down and put the values all the way, write it out again, go for it. If it helps you, great. But if you want to know just eliminating that one step, once you get rid of the 14 and 14, you're left with, once you get rid of those, you're just left with sine x, and I know that that's going to be an angle. Finding the angle is using my inverse function. Okay, so to do this, second function, sine bracket, sine 65, bracket 9, bracket divided by 14, and the bracket, and I get 35.6 degrees as my final value. And again, smaller side length, smaller angle. Here's my longer side length. It's going to create a bigger angle. So again, we talked about that with the sine law, and you're going to be using that especially with your applications on Friday. So knowing to look for those values and give you a little bit of a hint on that as well. Okay? All right, guys. Well, good luck with your worksheets. If you have any troubles, again, get in with the Google Meets on Thursday, and we'll take care of those functions or those questions for you and go from there. All right, stay safe, guys. We'll talk to you later.